Hello everyone, welcome to ICSE Guide to Success. These notes, they are a bit different and these are not proper notes. So I suggest you to read the textbook properly. But you know, these notes, they are taken from a topper. That topper has made such a good comprehensive style of formulas and all the correlations in the chapter of light that it becomes easier to understand and you can remember it for a life long. So if velocity increases, then it means the wavelength is more, optical density is less, refractive index is less, lateral displacement is also less, and deviation will be more. Okay. IN stands for inverse relation here, and D stands for direct relation. Lambda dash is equal to lambda upon mu. This is another formula. For the formula of refractive index, that is 2 with respect to 1, it is equal to V1 upon V2, that is velocity in first medium upon velocity in second medium, which is equal to C upon V2 upon C upon V1, which is equal to mu2 upon mu1. Factors affecting the refractive index of the medium. First of all, it is nature of the medium, that is the speed of light, so it is an inverse relation. Secondly, physical conditions such as temperature is a direct relation with the refractive index of medium. Thirdly, the color or wavelength of light is inversely proportional. So, the refractive index of violet is more than the refractive index of red light. Secondly, its lateral displacement. For lateral displacement, you can remember RAT. RAT stands for refractive index, which is directly proportional, angle of incidence, which is directly proportional, and the thickness of medium is directly proportional to the lateral displacement. So the lateral displacement of lateral displacement of the violet light is more than the lateral displacement of the red light. Another formula, angle of deviation is equal to I1 plus I2 minus R1 plus R2. I1 is the angle of, I stands for angle of incidence, R stands for angle of refraction. R1 plus R2 is equal to the angle of prism. A stands for angle of prism. I1 plus I2 is equal to A plus delta. Angle of deviation. So this is the graph of angle of deviation. And to remember what properties are dependent on it, you can remember IMO. I is angle of incidence, M is material of prism, A is angle of prism, and this is the wavelength. And this letter is called as lambda. Wavelength is inversely proportional to the angle of deviation. Angle of prism and material of prism is directly proportional to the angle of deviation. But for the angle of incidence, the graph goes like this. First, okay, it goes. So first it decreases, then it becomes minimum. Angle of deviation is minimum, where it is equal to 2 into angle of incidence minus angle of prism. And then the angle of incidence increases. Then the angle of deviation also increases after that. So mu of fine is greater than mu of ground. What does it mean? That the refractive index of this glass is greater than the refractive index of a ground glass. Deviation. The angle of deviation for violet light is greater than the angle of deviation for red light. So the bending is more and it is closer to the normal. You can remember like that. And the refractive index is maximum for red light. Next, Snell's law. Sin r upon sin I is equal to m with respect to A. A is air, is equal to real depth upon apparent depth, is equal to um upon ua. Formula for shift is real depth into 1 minus 1 upon absolute refractive index of the medium. Next, for shift. The refractive index of the medium is directly proportional to the shift. The thickness of medium is directly proportional to the shift. And the wavelength, it's inversely proportional to the shift. So therefore, the shift of the violet light is greater than the shift of red light. You can remember it by RTW. Mu is equal to 1 upon sin C, sin 90 degree upon sin C. Do you know what a C is? Yes, it is critical angle. Critical angle, let's define it. It is equal to angle of incidence in denser medium corresponding to which angle R in rarer medium is equal to 90 degree. Let's learn what are the factors in it. Color of light is directly proportional to the critical angle and temperature is directly proportional to the critical angle. Directly proportional, it means that if the color of light it is more, then the critical angle will also be more for that light. It doesn't mean that the color of light more. It means about the wavelength of the light or the refractive index of the light. TIR, total internal reflection. When does it happen? When ray of light traveling in a denser medium is incident at surface of rarer medium and angle I must be greater than angle C, that is angle of incidence must be greater than critical angle for the pair of media. Please write it or else you'll lose 1 mark. The ray is totally reflected back into the denser medium. Let's learn the different ways in which you can refract light through the prism for obtaining something. For example, in periscope, the principle that is used is this figure. You can take a screenshot if you like. So this is to deviate a light. The purpose is to deviate a light ray through 90 degree. Secondly, to deviate a light through 180 degree. This is applied in binocular and in camera to invert images. This is camera, I think. To invert images without the loss of intensity. Next is to erect an inverted image without deviation. You know, these figures, they come for 2 or 3 marks in your exams. So please practice these questions. Is used in slide projector. This is the entire electromagnetic spectrum. This is radio waves, microwaves, infrared waves, the visible light, UV, X-rays, and gamma rays. This visible light, it ranges from 4000 angstroms to 8000 angstroms. Infrared radiations, some important points. They are used in photography at night and in mist and fog. Very important question. Because they are scattered less by the Earth's atmosphere due to their long wavelength, so they can penetrate appreciably inside the atmosphere even in fog. Secondly, used in dark rooms for developing photographs. This is because it provides some visibility without affecting the photographic film. Thirdly, used in signals during war, as they are not visible and they get not much absorbed in the medium. Thank you so much.